Hi guys. Okay, this video is going to cover the 9-3 section, which is hyperbolas. Here's your frame game for today. The frame game from last week was buckle down and study, which is obviously something you need to be doing right now. Okay, let's get to chapter 9, section 3. So this is actually where we're going to stop for both a quiz and a test at the end of 9-3, which wraps up all the conics. So the last conic that we're going to talk about is hyperbola. And it basically is two parabolas in which they point outward in the outward direction from each other. By definition, it's the set of all points xy in a plane. The difference of whose distance from two distinct points is the foci is a positive constant. So there's a couple differences with the relationships between A, B, and C with ellipses. Between ellipses and hyperbolas. And then obviously the way that we graph this is a little bit different. And we'll point out all that stuff. But you still have things like vertices and focuses or foci. Those are still part of the graph. So the parts of the hyperbola, the graph of the hyperbola has two disconnected parts called branches. These curves or parabolas, like we used to call them, are actually called branches. The line through the two foci that intersects the hyperbola at 2 points is called the vertices. So if I were to draw a line through both of these, it would intersect this branch here and this branch here. Those are called your vertices, which again, we kind of used to. The line segment connecting the vertices is called the transverse axis. So this line that we just talked about is really like an axis of symmetry for both of those, and it's called the transverse axis. And the midpoint of the transverse axis is the center of the hyperbola. So we've done center for ellipse and circle, in which your object or your shape went around it. This time it's in the middle and it's pointing away from it. Now this one that we're looking at here, notice that here's A. A is still the distance from the center to the vertex. And C is still the distance from the center to the focus. And then you'll use B a little bit different here because we're about to get some asymptotes.
All right, the standard form of the equation of a hyperbola depends on whether the hyperbola's transverse axis is horizontal or vertical. Just like with ellipses, you have horizontal and you have vertical. So a horizontal one has the branches that point right and left, and a vertical one has the branches that point up and down. So there's a lot of stuff going on these, and we're going to kind of like just zoom in on a little bit. You can see that the vertices are here and here. The foci are here and here inside those curves, and now we see where B is. So we're going to identify the center on our hyperbola. We're going to count. In this case, if it's horizontal, which we'll talk about how you identify that in a minute, you're going to count right and left the A. You're going to count right and left the C. And you're going to count up and down the B. And then if you make this little box that is made from the lengths of A and B, and you draw, these are called your asymptotes, the X that goes through the corners of those, then you can make your branches in those spaces. So we'll definitely have a lot of examples on that, but this is where it comes from. The B, again, is called the covertex. So A is vertex, B is covertex, and C is your focus. That's a horizontal one. So in a vertical one, now we're going to count up and down your A. So we're going to identify the center. We're going to count up and down the A. We're going to go right and left the B. And we're going to go up and down the C. We're going to make the box based on the A and the B. And then draw your asymptotes through the corners of that box. And then draw your branches inside those asymptotes. Okay, so the standard form of the equation of hyperbola depends on whether or not the hyperbola's transverse axis is horizontal or vertical. So we just talked about this. The difference between what we just talked about and this is the shifted center. So if you go back to that last example, notice that it was always in the middle. It was always on 0, 0 starting. Now we're shifting the center off to wherever HK is. So if I have a number in the top with the H or with the Y or the X, now I know that there's a shift off center. If it just said X squared and Y squared, I would know center's at 0, 0. But if there's a number following the X or a number following the Y, now I know my center has shifted. Everything else is still the same. we would still count from the center to the right and to the left, whatever A is. So if it's a horizontal one, I'm going right here A, left here A. It's just that I'm not starting at 0, 0. I would also go up and down B to make the box. And for my focus, I'm going right and left C. So everything else is still the same. It's just that your center is no longer at 0, 0. If it's a vertical, then again, my center is in the middle there. I'd go up and down A to get my vertex. I'd go up and down C to get the focus. And I'd go right and left, whatever B is, to get the co-vertices. Okay, we're going to look at some more in depth with the equations. So the standard form of a parabola with the center, oh, this got cut off. This should say center. At HK is this. So notice the order is important this time. With an ellipse, we identify if it's horizontal or vertical based on A being the larger number. And if that larger number is underneath the X, it's horizontal. If the larger number is under the Y, it's vertical. This time, A doesn't have to be larger, but A always comes first. So whatever is first, that denominator is your A, and the variable above it determines if it's horizontal or vertical. So because this is starting with the X squared, this is a horizontal. Because this is starting with the Y squared, this is vertical. So this hyperbola would look something like this, and the second hyperbola would look something like this, obviously with a shifted center. Notice just like the ellipse, it's also equal to 1. So if your equation is not equal to 1, that's going to be your first step. The second part is just what happens if my center's at the origin. So if my center's at the origin, I lose the H, the K. But if X is first, it's still a horizontal. If Y is first, it's still a vertical. Now, we used to call the minor and major axis with ellipses. This is called transverse and then conjugate. Transverse is just like the major axis, that's 2A, and the conjugate is 2B. This also tells you that C squared equals A squared plus B squared. So remember with a ellipse, it was C squared equals A squared minus B squared. Now there's a plus. So the two big differences, obviously, in addition to just the shape of them, are that the A is larger in an ellipse. It's first with a hyperbola. And C squared equals A squared minus B squared with an ellipse. It's C squared equals A squared plus B squared with a hyperbola. Okay, let's look at some examples. So this says find the standard form of the equation with the hyperbola with a foci of negative 1, 2 and 5, 2 and vertices 0, 2 and 4, 2. So I'm going to pull in a coordinate grid and I'm going to plot this information. So hyperbola foci at negative 1, 2. There's a foci or focus, and then 5, 2. There's my other focus. Vertices at 0, 2 and 4, 2. So already you should be able to say, okay, I know this is going around the focus, which means this is a horizontal hyperbola, which means X is going over A. So I already know that just from that little bit of information. Now I have to find my center. So I want to find the point in the middle of the vertices and in the middle of the foci. So if there's 1, 2, 3, 4 points here, then the center is going to be at the middle of that, which is 2, 2. You can also find the midpoint. So if you wanted to just find the midpoint, you would add the 2 x's, divide by 2, add the 2 y's, divide by 2. Either way, we get the center is 2, 2. So now I know my numerators, x minus 2 squared minus y minus 2 squared. Remember, the A is the distance from the center to the vertex. So we have the vertex already. It's here. 1, 2. 1, 2, that means A is 2. And so this would be 2 squared. And now we got to find B. Okay, then the last thing I need is what B is. So we already know that C squared equals A squared plus B squared. If C is the distance from the center to the focus, 1, 2, 3, C is 3. A is 2. 9 equals 4 plus b squared. And b squared equals 5. So I actually don't need b by itself for this question. I need b squared. So I could write that it's 5, or I could write that it's the square root of 5 squared. It doesn't matter. This becomes 4, and there's my resulting equation. X minus 2 squared over a squared, which is 4, minus y minus 2 squared over the square root of 5 squared, which is 5, equals 1. And there's the standard form of your hyperbola. Okay, the last thing we have to identify with the hyperbola are the asymptotes. So each hyperbola has two asymptotes that intersect at the center of the hyperbola. They make an x. The asymptotes pass through the corners of a rectangle of the dimensions 2a by 2b. So if I extend it in a in both directions and b in both directions, then I'd get my little box or rectangle. And then I want to pass through the corners, making sure that it passes through the center here. So there's my center. Okay, this would be right and left A and up and down B. And then you'd make that little box and pass your asymptotes through the corners of the box. And that's how you know how wide to make your parabolas or your branches. Okay, once you've, that's how you graph them. If you want the equations of the asymptotes, then here are my equations. It's y equals k, which is what follows the y, right? The opposite of what follows y, plus and minus b over a if it's horizontal, times x minus h. It's y equals k plus or minus a over b if it's vertical, times x minus h. So notice that this is a plus and minus because there's two equations for each of those because there's two asymptotes. Okay, so this one says sketch the hyperbola whose equation is. So I'm going to start by looking at my equation and asking if it's equal to 1. And do I have to complete the square? So this time I only have the x squared, not an x squared and an x, which means that that would be complete the square, which we'll get to in a little bit. Right now I just need to divide everything by 16 so that I have it equal to 1. So I'd get x squared over 4 minus y squared over 16 equals 1. Now I've got it in standard form. And there's lots of information I can already get from this. 1 is my center is 0, 0. 2 is because x comes first, this is horizontal, which means a squared is 4, making a 2, and b squared is 16, making b 4. So I can graph what I have already. I'm going to pull in a coordinate grid again. Okay, so I'm going to graph my center at 0, 0. And then I'm going to go, because again it's horizontal, I'm going right and left the A. So I'm going right 2 and left 2, and those are my vertices. And then my B is 4, so I'm going to go up 4 and down 4, and those are my co-vertices. So now what I want to do is make myself a little box that connects those lengths. Draw the asymptotes through the corners of that box. Go back to my vertices and draw my parabolas as wide, or my branches as wide as those two asymptotes to the right and to the left because it's horizontal. Now it didn't ask for the foci, but if it did, I would do c squared equals a squared plus b squared to find where the foci were, which would be, let's say, c squared equals a squared plus b squared, or 4 plus 16, which is 20. C would equal the square root of 20, which is approximately, it's a little bigger than 16, but less than 5. So it's like 4 point, let's just say it's 4.5. If I was to write it exact, it'd be 2 root 5. So it'd be to the right, 2 root 5, and to the left, 2 root 5. So I know, again, it's like 4.5. It'd be like somewhere in here. That would be my foci. The last thing it could also ask you for was the asymptotes. So remember the asymptotes, when it's horizontal, is y equals k plus and minus b over a x minus h. So y equals k is 0, plus and minus. Remember, my b is 4, my a is 2, x minus h is also 0. And that would simplify to be y equals plus and minus 2x. So if you compare that to the box that we drew, the b here is 0, right? So I would have started at 0, and I would have gone up 2 and over 1, up 2 over 1, and I would have made that line that passes right there for the positive. And then negative 2x would be start at 0, 0, go down 2 to the right 1, down 2 to the right 1, and there's my other asymptote. So you can graph it based on those lines, or you can make the box. I honestly think the box is a lot easier most of the time, but it's totally up to you how you do that. All right, this one says, put the equation in standard form, find the asymptotes, and then sketch the hyperbola given by. And this time, it is not in standard form. There is a complete the square component because you have both an x squared and an x. The good news is you don't have to do it with the y. You only have to do it with one of the variables. Sometimes you'll have to do it with both. So let me group the 4x squared and the 8x, negative 3y squared, and bump the 16 to the other side. I'm going to have to complete this square, so I'm going to take the 4 out, leave the space, minus 3y squared equals negative 16. Take that 2, divide it by 2, which is 1, and square it, and it's 1. Add that in here. Before I add it over here, I have to multiply it times the 4. So I get 4x plus 1 squared minus 3y squared equals negative 16 plus 4 is negative 12. Now I need to get it equal to 1. So I'm going to take and divide everything by negative 12. So not only is this changing the values, but this is also changing which of my variables is positive and which one's negative. 4 goes into 12 3 times, so this is x plus 1 squared over negative 3. Negative 3 and negative this is 4, but it comes positive, equals 1. Now, because this is negative and this is positive, I need to switch the order. So it would be y squared over 4 minus x plus 1 squared over 3 equals 1. Here's my standard form. So what do we know from this already? We know that because y is first, this is vertical. We know the center, what follows x would be negative 1, or the opposite of what follows x would be negative 1. What follows y would be 0. We know a squared, which is what's first, is 4, making a 2. And we know b squared is 3, which makes b square root 3. Now let's graph what we can. Center at negative 1, 0. I'm going up and down the a this time. So up 2, down 2, right and left the b. Now b is root 3, which is pretty close to root 2. So let's say this is like a 1.8. We're going to totally approximate that though. Make your little box. Have your asymptotes run through the corners of those boxes. It's not the straightest line, but you get the point. My vertices were here and here. Bounce off of them. So if it had asked you information, I would have known the center, the vertices are here and here, which is negative 1, 2, negative 1, negative 2. The co-vertices, which are here and here, we went right and left root 3. So we're going to take our center, which is negative 1, 0, and it's the right and the left for the b, so we're going to add and subtract root 3. So I would do -1 plus root 3, 0, and -1 minus root 3, 0. And those are the covertices. If it had asked for the foci, I would need to know c squared equals a squared, which is 4, plus b squared, which is 3, sorry. C squared would equal 7. C would equal square root 7. And that we add on to the y because it's up here and down here. So I would take my center again, which is -1, 0, and add and subtract root 7 on to the y value. So my foci would be -1 root 7 and -1 negative root 7. Root 7 is a little bit less than 3, so we would have counted 1, 2, and almost to 3, 1, 2, and almost to 3, and those would have been the foci. So this is my vertex, covertex. So there's a lot of information that you can find from this, and you can even find the asymptotes. So it would be, remember, it's y equals k plus and minus. Now it's vertical, so it's a over b x minus h. So y would equal, my k is 0, my a is 2, my b is root 3, x minus a -1 becomes plus 1 there. Two things. This goes away, and this needs to be rationalized. 2 root 3 over 3, x plus 1. These would have been your asymptotes. So when you complete your quiz on the all of 9193, the complete the square, it will be a question almost exactly like this, except that what you're given could be a circle, a parabola, an ellipse, or a hyperbola, and you'd need to find all the information that we just found. Okay, here says put the standard form of the equation, or find the standard form of the equation of the hyperbola having the vertices 3, -5, and 3, 1, having asymptotes y equals 2x minus 8 and y equals -2x plus 4. So again, I'll graph it. Three, -5, and 3, 1. Those are the vertices. And my asymptotes here. So those aren't perfect. So I would always want to figure out my center from my vertices. Remember, it's the midpoint between these. So I would add the 2x's divided by 2, add the 2y's divided by 2, and that's going to give you the midpoint, which is the center. And 3, -2, there's my center. Now I can determine the distance from the center to the vertex, which is 3, and that's your A. The only other piece of information I need to get the equation, because I also know that this is vertical. So it's a y over A minus x over B squared. The other thing I need is the B. So because I don't know the focus, the only other piece of information it gives me is my asymptote. And really the only piece of information you need from the asymptote is the slope, because that with a vertical asymptote or vertical hyperbola, remember it's plus and minus a over b. It's y equals k plus and minus a over b x minus h. So what we need is that slope part, which in this case is 2. So if a over b equals 2 or -2, because it's the same, right? This is +2, this is -2, it doesn't matter. And I know a is 3, then I can find b by cross multiplying here. 2b would equal 3, and b would equal 3 over 2. So now I have b, 3 over 2. Now, this is where it gets a little bit more complicated because when I go to plug that into my equation, let's see what happens. I get y minus a negative 2 becomes plus 2 squared over a squared. A was 3, so this is 9, minus x minus 3 squared, because that's the x coordinate, over 3 halves squared, which is 9/4, equals 1. Now, you cannot leave the fraction within the fraction. So what happens here is when I would flip this, so if I were to multiply by 4 over 9, the 4 would go to the top. So the shortcut is just bring the denominator of the denominator to the top. So this would be y plus 2 squared over 9 minus 4 times x minus 3 squared over 9 equals 1. That's the standard form of your equation. Okay, the good news is what's left is super easy. The eccentricity of the hyperbola is c over a, just like the eccentricity of an ellipse. This time, the bigger the number is, the flatter it is. So if I have an e that's really large, that's, this time it's not in between 0 and 1 because c can be bigger. Well, c has to be bigger than a, sorry. Because c squared equals a squared plus b squared, right? So c is always bigger than a, which means that this is not going to be in between 0 and 1 like the ellipse is. It's going to be greater than 1. And the bigger that number is, the flatter the curve. The smaller that number is, the more narrow that curve is. So again, this is something that could just help you if you look back on the last, example and you say, okay, what's the c over a? If it's a large number, that should be wide. If it's a small number, then it should be narrow. And the very last thing is just a way to identify it because we're going to group all these together. So if you have an equation and it's in the form where you have the x squared, it's not in standard form, it's in general form, which means that if you have an x squared, you have an x, a y squared, and a y, you actually can't use this with the xy term. That requires rotation, which we're not going to talk about, so don't stress about it. But if I look back at that last example, so this is the last example that we had an actual equation in, the general equation. If this was mixed in with the parabolas and the ellipses and the circles, and I needed to know what kind of conic it was, I would look at the a, which the a is what's on the front of the x squared term. Here, a would be 4. I would look at the b, which is what's on front, or sorry, the c, which is on the front of the y squared term, and this is a negative 3. And then see which relationship this fits in. Are they equal? No, that makes it a circle. When I multiply them together, do I get 0? No, that would make it a parabola. When I multiply them together, is it greater than 0, which is positive? No, that would make it an ellipse. When I multiply them together, is it less than 0, which is negative? Yes, this would be negative 12, which makes it a hyperbola. So this is a quick way to figure out what kind of conic you have before you put it into standard form. So you could use it on something like this. This just says classify the graph of each equation. So we're not actually graphing any of these. We're just classifying. So remember, a is what's in front of the x squared. It'd be 4. C is what's in front of the y squared. There's no y squared, which means it would be 0. Now, when I multiply these together, I get 0, which means that this is a parabola. Looking at b, a is what's in front of the x squared. C is what's in front of the y squared, negative 1. When I multiply these together, I get negative 4, which means that this is a hyperbola. Look at C. A is 2. B is 4. Multiply those together, it's 8. That means it's positive, which means this is an ellipse. Looking at D, A is 2. C, sorry, this should have been a C. C is 2. They are the same, which means this is a circle. All right, so that wraps up what you're going to need to know, not only for your quiz, but also for your test. So we're going to practice again a little bit with the putting an equation in a standard form, identifying what kind of conic it is, and then identifying all the next. That's what we'll do the next time that we meet in the next video that'll be posted. And then you'll see that you're going to get a video quiz, and that's what your video quiz will be. And then your overall test will be on 9.1 to 9.3, which has all the conic stuff in together, but up until this point. All right, have a great day, guys. Good luck on your homework. Make sure you go on a WebAssign to get that homework. If you're, again, frustrated at the graphing, please don't stress about it. Just graph on Notability. And have a great day.